Number 1. The distance traveled by an object thrown vertically upwards with a velocity of 120 meters per second in 9th second is. Right. Here we know the object thrown vertically upward. Right. So it is under gravity. Right. So if an object project upward with a certain velocity, right, we know it is travel under gravity. Right. So value of gravitational acceleration we know it is 10 meters per square second. So meaning of this 10 meters per square second is, we know it is change in velocity in 1 second, right, the value it is 10, right. So it means every single second it change velocity in 10 meters per second. When we project upward, right, in every second it decrease in 10 by 10, right. If it is released from a certain height, right, and we release at rest, right, we know it is gradually increase by 10 by 10 its velocity, right. As example, if we release from rest, after 1 second it is 10 meters per second. In next second it is 20 meters per second, right. Next second, like that it is increasing 10 by 10. Now here projecting 120 meters per second, right. So every single second it decrease in 10 by 10. So here in the next, after 1 second it is 110, another second 100, like that, right. So based on that, right, we can consider, right, the time taken to become rest, it may become 0, it means 12 seconds, right. In every single second is decreased by 10 and 10, it is decreased 10 by 10, it means 10 seconds is taken to decrease until 0, right. So it means the maximum height, we know velocity becomes 0 at the maximum height, right. So here, so the time taken, no need to apply the equation of motion, right. If you know the if you know the exact meaning of the gravitational acceleration, right, so you can get the answer or time taken to reach to the maximum height based on that definition, right. Okay, now here ask about the distance traveled by an object thrown vertically upward with a velocity of 120 in 9th second is, right. Here in the 0 second, right, if you know the velocity at 8th second, here is the 9th second, this is the time of 9th second. If you know the velocities, here velocity and here velocity, right, you can get the answer, right. So we know it is project is 120, right, after 8 it should be 14, right, 14. So then it is 30. The distance here, the x should be, we can find s equal v plus u over 2 into t, right. V it is 30, u it is 40, it is 70 over 2, 35, t it is 1 second. So distance should be 35 meters, answer should be 5. When an object dropped from the top of a building, distance dropped in first 2 seconds divided by distance dropped in first 3 seconds is equal to, ask about the ratio, distance, about the ratios, right. So here if we know the distance, right, here is the drop, here t equal 0, right, here after 2 seconds, here after 3 seconds, here x2, here x3, ask about the ratios, right. So if we consider in 2 seconds, the distance travel in 2 seconds, right, here we can apply the equation s equal ut plus half at squared, right. And MCQ no need to write the equation, right, you know the equation, right. So no one check your draft paper, so just apply x2 here, then u0, right, half here under gravity, so 10, right, 2, this 2 is square, right. So actually here you can see a, half, u are common. Yes, it is proportional with t square, right. Now here it is asked about x2 over x3, right. It means the ratio between the time taken, right. So here then you can find it is here second, right, here the third step. So it means here it is 4, it is 9, 4 over 9, right. So on, right. So right, we have to right, we have to try to find some relation, see, like the proportionalities, right. Maybe the if we use some equations, right, always you try to find the relationships, right. So this is the MCQs, no need to write the whole equation, right. Okay, question number 3. The fractional error of a reading taken for a diameter of a sphere using a caliper was 1 over 100. The number of spheres to be placed in a row to make a fractional error of the reading of a diameter of a sphere 1 over 10 is, right. Okay, here it means if we suppose when the reading, when n number of spheres here, right. Here suppose there are n number of spheres, right, like that, right. If we consider the total distance, right, the distance of right, total distance of spheres, it is d, right. Let's consider each diameter, if it is d, there are n number of, right, you know, it is d equal n number of diameter of each sphere, right. Now here it is considered about the fractional error, right. Now here according to the question, it is here 1 over d, here n, here 1 over 100, right. So n it is equal to 10, right. It means we have to use 10, right. Answer 2. Number 4. At t equals 0, car A starts from city X with a certain speed and continues to travel at that speed. After speed greater than A from city X and overtakes car A at a distance of S. If car A travels at twice its initial speed and after t0, car B travels at twice its initial speed, the distance B must travel to overtake A is, right. So you have to understand the question, right. First of all you have to understand the question. Here if you travel initially, suppose it is V, right, VA, right, here travel as BVB, right. After t some time, right, B start its motion, right. If we here we consider the first instance, right, here if we consider now is travel, suppose the distance when it is passed, suppose it is S0, right. So here according to the A, it is, we know here it is uniform velocity, right. So S equal Vt equation we can use, right. So according to the A, it is VAT, right. Suppose after t0 time, B start its motion. Now to B it is S0, the same time, the same distance are traveled by two vehicles when B pass A. So here according to the B, the distance traveled, the particular time, it is also s naught. Now velocity of v, now vb. Time taken, it is t minus t naught, not t, right? Okay, so here v s naught, it is v a t, here v b t minus v b t naught, right? So we can get the expression for the time taken t, right? So here v b t naught t, so here t common, so v b t naught divided by the vb minus va, right? Now in the second instance, right, in the second instance, let's consider the second instance, right? What happened? Now v, it is double initial velocity, right? After t naught time, right, the velocity of initial velocity of b vehicle also double. Now what? Here suppose the time taken now in the second instance, suppose it is t1 time taken, when is time taken by the b to pass a, right? Now the time taken to a in second instance, right, it is now it is 2, this is time taken. If we consider 2, now it is vb, it is double same time, right? Right, here also time taken after t naught according to the question, right? Same after, suppose in the first instance, right, b starts its motion after 2 seconds, right, when a depart, right? He also at same 2 seconds, right? It means t naught is not changed. Now here v also double, va also double. Now here 2 common, so here to here again you can see t and t1 are equal. It means time taken the first instance to pass b, right, pass a is equal to the second instance, right? So now it means the time taken is constant, no? So according to the equation here time taken, it is constant, right? S naught or distance or displacement proportional to the velocity. It means when the velocity is double, what happened to the distance? Distance should be double. So it means in the initial instance, the time the distance travel when we pass the a, it is s naught. Now it should be 2s naught in second instance, right? Okay, so answer should be 2. Number 5. The sum of the 7 vectors a, b, b, c, c, d, a, d, a, f, f, e and e, d, right? Here there is a diagram, right? So here if we start, right, from the a, right, we can move around the 3 paths. We can move a to b, b to c, as well as a to d, right, and a to f, f to e, right? Here I select this path first, a to b, b to c, c to d, right? So and when d, we cannot move a to o, e because arrows are opposite, right? So we can move along the direction of the arrows, right? So we know the resultant of a vector, right, is given by the initial to final point, right? So here initial a, now b, c, d, so final point it is a to d, right? So here resultant of a, b, c, d, it is ad, right? Now we can move again another path, a to f, f to e, e to d, right? We cannot move d to a because arrows are opposite. So this path, the resultant of AFED path also again initial to final AD, right? So there's a single vector towards the AD, so it is also added. So sum of this vector diagram, it is 3AD. So answer 4.